Hello, we are the Avengers. Not a team, we're a time bomb.
We are doing the group video presentation for AGB 212. Throughout the video, we're going to take you through a problem, and throughout the problem, we're going to explain what an indifference curve is and how to generate a demand curve.
Sid is a commuter student at his college. During the day, he snacks on cartons of yogurt and the house special, sandwiches, at the student center cafeteria. A carton of yogurt costs $1.20. The student center often offers specials on the sandwiches, so their price varies a great deal. Sid has a budget of $36 per week for the food at the center. 5 of Sid's indifference curves, recognized by the graphs, are given by the schedule below. The points listed in the tables correspond to the points shown in the graph. Part A. Use a set of Sid's indifference curves shown as a guide in drawing your own graph grid. Draw Sid's indifference curves as a budget line, assuming sandwiches cost $3.60. Identify the point at which he maximizes utility. How many sandwiches will he consume? How many cartons of yogurt?
Okay, so part A wants us to graph the indifference curves and the budget line, assuming that Sid's budget is $36 and sandwiches cost $3.60 and cartons of yogurt cost $1.20. So on this graph, we have the 5 different indifference curves, and an indifference curve is just like a combination of 2 goods that yield equal levels of utility. And then it also said that it wanted us to graph the budget line. So this pink line is our budget line, and a budget line just shows graphically the combinations of the 2 goods that a consumer can buy with any given budget. And like I said before, the budget was $36. So the point where he maximizes his utility is at point C, and at this point he is consuming 5 sandwiches and 15 cartons of yogurt. Hi, can I order?
Yeah, we're having a social today.
Oh really? I'll get to that.
Alright, yeah, they're quite cheap.
Okay, good.
Hey, what's up, man? Notice you're checking out these yogurts. And right now we got a sale, right now 1 for $5. So if you're interested, just let me know, man.
Dude, can I get 16?
Yeah, let me check the back here and see if they have some more.
Sick, thanks, man. Hey, have you guys heard about our sandwich and yogurt specials this week? Dude, we're on sale, 2 for 1. You guys want to buy some? Yeah. Dude, sweet. Thanks, guys. Yeah. Number B. Now suppose the price of sandwiches is cut to $1.20. Draw the new budget line. Identify a point at which Sid maximizes utility. How many sandwiches will he consume? How many cartons of yogurt will he consume?
So the new budget line, the price says now for sandwiches is changed to $1.20, equaling the price of yogurt, which is $1.20 also. This causes the budget line to move out to the right because now you can buy more sandwiches, you have more quantity, and that allows you to get more units of sandwiches per week. Therefore, the budget line increases, allowing more indifference curves to enter into the table section of the graph. So for right now, we have a higher maximizing utility of point J, which allows us to have 20 yogurts and 10 sandwiches per week. And furthermore, the price change of decreasing sandwiches from $3.60 to $1.20 allows a movement along the curve, giving us more points available. The nature of the decision rule is that when marginal benefit is greater than marginal cost, you will keep increasing the quantity of goods you want to buy. However, when marginal cost is greater than marginal benefit, you will have less desire to obtain more quantity of those goods. So what this graph represents, especially at point J, is that you get the maximization of the utility, showing that you have no desire to move. A, you have a budget line, so you can't, it's unattainable to move higher than into this section, this is unattainable. But Maximization of utility at point J shows that we have fulfilled the decision rule, meaning that our marginal cost, our marginal benefit is still greater than marginal cost, but it's at a point where if we moved on and obtained another unit of quantity, it would cause our marginal cost to be greater than our marginal benefit. Therefore, at point J, we are fulfilling the maximization of utility and also fulfilling the decision rule. Thereby, it also shows you where to stop, in essence, because you now know as a consumer you do not want to go above the budget line because you cannot. And furthermore, you do not, this is the highest utility you can obtain, meaning that all of these are lesser of value in your eyes or your perspective in comparison to point J.
Now question C states, now draw the budget lines implied by a price of yogurt of $1.20 and sandwich prices of 90 cents and $1.80. With the observations you've already made for sandwich prices of $3.60 and $1.20, draw the demand curve. Explain how this demand illustrates the law of demand. This is what we will do now.
Okay, so we're looking at a normal demand curve. Usually we're dealing with one product, and in this case, let's just say it's yogurt. So say your budget is $36. You're going to want to buy as much yogurt as possible within your budget. And that's a movement along the curve, having to do with the quantity demanded and at what price that yogurt is. However, when you're dealing with an indifference curve, you have two different products, which we have yogurt and we have sandwiches. And at this time, your budget is still $36, and so you want to buy the most amount of each product, but stay on your budget line. So you want to be able to spend as much money as possible without going over your budget of $36.
Okay, so like I just said, this is the indifference curve, which deals with two different products, yogurt and sandwiches, and right now your budget is $36. And sandwiches are the price of 90 cents, and yogurt is at the price of $1.20. So you try to maximize the amount of the products, the two products that you can buy, and your maximization of utility is at point I along your new budget line curve. And so point I is when you can buy 8 sandwiches and 24 yogurt cartons. Okay, so now our sandwiches are $1.80 and our yogurt is $1.20, which means when you buy the maximization of each product that you can, your maximization of utility at point F, which is 21 yogurts and 6 sandwiches, and this is as much as you can buy of each product with your budget of $36. And the budget line moved in this blue curve right here.
Okay. So the law of demand says that the higher the price, the lower the quantity demanded, because consumers' opportunity cost to acquire that good or service increases, and they must make more trade-offs to acquire the more expensive product. And this law of demand is heavily prevalent in this situation, where we have the shift from here, from this curve, to this budget line here.
Trade-offs are when you can buy either more or less of an item depending on the price and the ratios. So if you have apples, which 5 bags you can buy for $2, and you have oranges, 3 bags, which you can buy for $1. But the price of oranges changes and there's an increase in price. So say the price goes up $1. So now oranges, it's $2 for 3 bags. And you have apples, $2 for 5 bags. So obviously you're going to want to buy apples instead of oranges because you're going to get more of the product for worth your money at the same exact price because the ratios are the same for each price.